Hi! Vision is really an amazing property. Have you ever thought why we need both the eyes for seeing? Is a single eye not sufficient for vision? Vision becomes perfect only when both the eyes are involved. When only one eye is used, only a two-dimensional view within an angular width of 150 degrees is possible. But when an object is viewed using both the lenses, a three-dimensional and wide vision with an angular span of 180 degrees is possible. It is the brain that creates the perception of the distance of the object by unifying the vision of the two eyes. So far, we have learned how different objects in nature are seen by us. But why do they appear different colors when exposed to sunlight? To find the answers, we have to learn some more phenomena of light. Let's familiarize ourselves with some activities. Pass sunlight through a prism and allow it to fall on a screen. What can you observe here? Yes, we can see different colors, can we? They are violet, indigo, blue, green, yellow, orange and red. If we combine the first letters of these colors, we get a code VIBGYOR. Here, the sunlight gets split up into component colors. That is, when we pass the sunlight through a prism, it gets split up into its component colors. But is it the sunlight alone that gets split up into component colors? No. If we cover the glass cover of a torch with a black paper, make a hole on its center of the paper and let the beam of white light from the torchlight fall obliquely on the prism, we can observe the same splitting up of light into their component colors. The colors pattern will be the same: violet, indigo, blue, green, yellow, orange and red, or in short, VIBGYOR. Any light that is composed of more than one color is a composite light. The phenomenon of splitting up of a composite light into its constituent colors is called the dispersion. The angular array of colors formed by dispersion is the visible spectrum. If we observe the visible spectrum, we can identify that the color which deviates the most due to dispersion is violet and the color which deviates less is the red. The extent of deviation is dependent on the wavelength of the colors. So, what do you mean by wavelength? We know that the light travels as waves. Waves contain both crest and troughs. Wavelength can be defined as the distance between two successive crests or troughs of a wave. Among the component colors of light, red has a longer wavelength and violet has a shorter wavelength. That is, in VIBGYOR, from V to R, the wavelength increases. So, when light passes through a prism, the color with shorter wavelength undergoes a larger deviation. On the other hand, the color with longer wavelength undergoes a smaller deviation. This explains the fact that violet undergoes a large deviation since it has a shorter wavelength and red undergoes a smaller deviation since it has the longer wavelength. Light undergoes refraction when it enters the prism and it comes out of the prism. We can say that the extent of deviation is dependent on the wavelength. Therefore, the colors undergo deviation at different angles and get separated. This is the reason for dispersion. We all love to see rainbows, don't we? Rainbows appear either before or after rain. One can never get tired of rainbows. Rainbows are such a beautiful phenomenon in nature. Why does the rainbow appear only before or after the rain? During this time, the amount of water droplets in the atmosphere will be high. When light passes through these water droplets, refraction happens twice and the total internal reflection happens once. The sunlight undergoes dispersion and split up into its component colors. Violet, having the shortest wavelength, undergoes the most deviation and occupies the bottom of the rainbow. Red, having the longest wavelength, undergoes least deviation and occupies the top of the rainbow. Other colors occupy with respect to their wavelengths. So, rainbow forms when light undergoes dispersion within the water droplets. There are many similar situations. On a sunny day, spray water into the atmosphere facing away from the sun. We can observe that the constituent colors appear in the water droplets. The sunlight undergoes dispersion and total internal reflection within the water droplets. Red color appears outside and violet color appears inside the arc. You may have observed that the rainbow always appears on the opposite side of the sun. If a rainbow is seen in the west, the sun will be on the east. That is, in the mornings, rainbow can be seen in the west. If a rainbow is seen in the east, the sun will be on the west. That is, in the evenings, a rainbow can be seen in the east. Have you ever wondered why rainbows got this arc shape? Line of vision is a line connecting the center of the rainbow and the eye of the observer. The rays of light incident on the water droplets must be parallel to the line of vision. Each ray of color emerging from the water droplets makes a definite angle ranging from 40.8 degrees to 42.7 degrees within the line of vision. Of these, the higher angle 42.7 degrees is made by the red. The violet makes the lower angle 40.8 degrees. So, the red color is seen at the upper edge and the violet color is seen at the lower edge. We know that the light rays undergo refraction and total internal reflection within the water droplets. The light rays emerging from the water droplets, which makes the same angle with the line of vision, have the same color. So, they appear to form an arc of a particular color. Thus, there are red light at the upper edge and violet color at the lower edge. All the colors are seen in between depending on their wavelengths. When the position of the sun is near the horizon, the rainbow appears to be bigger. When it's seen from an aeroplane, the rainbow is seen as a circle. When the sun is much above the horizon, the rainbow disappears. So, in this section, we have learned the component colors in sunlight, dispersion and the formation of rainbow.